Let's make sure we're live. Okay, we are live. So, we're talking about similarity in shapes today. That's what we're discussing, okay? Can anybody tell me what similarity means? What is similarity? What does it mean? Like, you're just telling me the word over and over. What does similar mean? It's not the same thing. That's congruent. What do you mean almost the same?
Like there's one thing that's not.
Okay. So, here's the lowdown, the skinny on similar. Similar means that they're the same shape, but they're different sizes. So the angles will be the same. See how we have 59 and 59? And then we have 35 and 35. And of course, y'all know based on the third angle theorem, if these two are the same, those have to be the same also, right? So they have the same angle measurements, which means they're the same shape. But look at the sides. Now, what we do have to do is we have to determine, are these similar or not? And to figure out if these are similar or not, we have to determine what their scale factor is. Now, scale factor is the number you would multiply one shape by to get the other shape. We could do that by doing this shape divided by that shape or that shape divided by this shape. It doesn't make any difference. I personally like to do the big number divided by the little number. I just think it makes more sense, right? So we would compare this 10.5 to this. Actually, let's back up and not do 10.5 first. So we would compare the side that's across from the 35-degree angle, that's 6, to the side that's across from the 35-degree angle, that's 4. So we would do 6 divided by 4, and then simplify that number. What is that number simplified? 3 over 2, right? Then we're going to do the same thing with the angle, the side across from the 59-degree angle. So we would have 9 over 6, right? What's that going to be? 3 over 2 again, right? So they match up. Then we're going to do the 10.5 and the 7, right? So, I don't know, my brain and my hands just didn't cooperate for a second. So 10.5 over 7. Now if we grab our calculator and we do 10, gotta turn it on first. 10.5 divided by 7. What's the easiest way to convert that to a fraction on your calculator?
2. Oh,
Math.
Enter.
So enter, just like that, right? What do you get? 3 over 2. Since the scale factor is the same for every set of sides, that means that these two triangles are similar. So we need to write a similarity statement because that's what the directions tell us. Determine if they're similar. If they are, write a similarity statement. So a similarity statement is just like a congruent statement. We're just saying this triangle is similar to this triangle. And you do it with symbols, right? So we're going to name this triangle here. So we're going to say triangle A, B, C is similar to, y'all see the little symbol for similarity? It's one squiggle, right? Similar to, and then we name this triangle, but we have to match up the angles that are congruent. So what matches to A? D. What matches to B? What matches to C? So that's triangle DEF. That is a similarity statement. Okay. All right, so let's look at number 2. Tell me what you notice. What jumps out at you?
7.5.
All the way around that 7.5. And then all the way around, that one's 3. So we actually can tell just by looking at these are going to be similar because all the ratios are going to be the same, right? Because all the sides are the same here, all the sides are the same here. So we know all the ratios are going to be the same. However, we do need to go ahead and do the math on this to figure out what the scale factor is. So we'll take our 7.5 and we'll divide it by 3, and that gets us our scale factor. What is 7.5 divided by 3? No, that would be 5 over 2, or what is it as a decimal? Because we can put it as a decimal. 2.5. So this is your scale factor, 5 over 2 or 2.5. And you can put it as a decimal. That's totally okay. Okay? Everybody good so far? So that is our scale factor. So next we just write our similarity statement, right? So our similarity statement, we're going to name this guy. Remember, you name him in order. So we say parallelogram, PQRS, so PQRS is similar, little squiggle, to parallelogram. And then we have to match it up. What matches to P? W. Matches to Q? What matches to R? And S. And that's your similarity statement. And that's all there is to that. We're just writing a similarity statement. You're just matching up your angles that are the same. Okay? Everybody good so far? Okay, so let's look at number 3 here. So on these, they're telling you in advance they are similar. These are similar angles. They're telling you we're similar shapes. And when I say the word similar repeatedly, it gets harder and harder for me to say it. Okay? So they are similar. We know they're similar. They're telling us straight up they're similar. We're trying to find this missing side right here. So we're going to do this one just using some little bit of common sense because it's real basic. But then we're going to talk about how it's going to get harder in just a second and how to make it easier for us. So what we're going to do is compare what compares to BC in this shape. So it's exactly right. So 26 divided by 2 would get us 13, right? That means to find x, what are we doing over here? So we take 13, divide it by 2, and that would be 6.5 or 6.5, right? That's simple. That's really easy. However, look at this one. It gets a little harder when we look at this, right? Now we could do it the same way. We could be like, okay, so this side and this side are similar sides. To get 3, to get 9, we multiply 3 by 3, right? That means we know that we'd have to multiply 4 by 3 to get this side. But then this side is x plus 5. So we'd have to set up like a little equation, right? Now we could do it. We could totally do it. As a matter of fact, first hour did it. They wanted to. So, and this is what it looked like, right? So this is what they did to get that, right? But remember yesterday us learning proportions? That's because it makes this easier. Okay, so what we're going to do is set up a proportion. We're going to set up a ratio of this side to this side, the numbers we know. So what is the ratio of this side to this side? 3 to 9. So then we're going to set up a ratio of this side to this side. So it's going to be 4 on top and then x plus 5 on bottom. Just like that, right? And then remember how we solve these? We cross multiply. So that means we're going to have 9 times 4, 36. And then 3 times all this stuff. So 3 times x and 3 times 5. Just like that. I'm going to have to jump mine up here. I ran out of room. And then we have this very basic little equation that we can solve. So what do we do to solve this? Subtract 15. And then we'll divide that by 3. So what is 36 divided by 15? 21? No. Yep, 21. And then what? Divide by 3. And what is x? 7. Now, all they asked us to find was the value of x. Okay. Now, on this one, they only asked us to find the value for x, so we're done with that. If they wanted us to find the side, we'd have to go put it in. But they didn't ask for that. Okay, look at number 5. All right. So, on number 5, what side is similar to PQ? How do you know which side? And it's not TU. It's UV. Now let's talk about how you know. You look at the angles. So you look for the angle with 1 mark, that's U. And then you look for the angle with 2 marks, that's V. So that's how we know that PQ is similar to UV, right? Yeah, they turned it. They tried to throw you off, right? So that means we'll set up 5 over 10 over 3. Now, let me just say, you technically are not supposed to put a fraction inside a fraction. You're not supposed to do that. But we're going to. Yeah, we're going to because it makes it easier to solve this problem, okay? So that's this side to this side, right? And then the other 2 sides that we have information about is this side and this side. Do those 2 match up? Are those similar sides? How many rings does S and T have? Do they have the same number of rings? Do R and W have the same number of rings? So those are similar sides. So we'll set it up. Because 5's on top over here, what has to be on top over here? 9. Okay? And X plus 1 is going to be on bottom. Now, all we have to do is cross multiply. So we're going to multiply 5 times all this. So that's going to be 5 times X is 5X. 5 times 1 is 5, right? And then I'm going to write down 9 times 10 over 3 because I want to talk about this one, okay? We could plug this in our calculator, but you know it's not necessary because this is actually some real basic math if we just think about it a second. We could multiply and then divide, but y'all know we could divide first and multiply because division and multiplication are a pair. They go together, right? So we can divide first and then multiply. It doesn't make any difference. If we divide first, which 9 can be divided by 3, right? How many times? What do you get when you divide 9 by 3? 3. So that just leaves you with 3 times 10, and we have 30 over here. See how we don't have to grab a calculator to do some math, right? So that gets us 5x plus 5 equals 30. Now, basic solving, subtract 5 from both sides, right? So 5x equals 25. But what does x equal? 5. Because we just divide by 5, x is 5. Now, we're actually done with that problem because they just asked for x. But if they ask us to find the side length, we have to go back and put it in, right? Okay, number 6. Jonathan, number 6, they really tried to trick you on this one. They flipped it around and they didn't give you any angle stuff. So you got to use a little bit of common sense here. So which side is going to match up to ML?
TS.
TS. Now let's talk about how you know that. Yes. So let's think about it. 8 is shorter than 10. What's going to be shorter? X minus 1 or X plus 2? X minus 1 is going to be the shorter side, right? So X minus 1 is going to go on the bottom. And then over here, what goes on top? 10. 10. What goes on bottom? X plus 2. So now we're going to cross multiply. So we're going to have 8 times this stuff. 8 times x is 8x. 8 times 2 is 16. And then 10 times this stuff. So 10 times x is 10x. 10 times negative 1 is negative 10. And now we just solve it. Right? So what would you do? Add 10? Well, I mean, it doesn't matter.
At the same time, minus x.
That actually doesn't make any difference when you're solving an equation. Adding and, look at me. Adding and subtracting are a pair. They go together. Right? Okay. And Zaylee said we could, at the same time, subtract 8x and get rid of the 8x over here. Okay, so we're getting rid of the 10 over here, the 8x over here. So that gets us 2x on this side and 26 on that side. Divide by 2, and x is 13. Y'all see how easy that is? How easy those proportions are? Okay. Now, I do want to point out to you that my first hour class, we did number 5 the hard way first. We actually made a mistake mathematically somewhere, and I never have went back to figure out where our math mistake was, and we got the wrong answer. But look how much work they had to do to come up with the answer. That's a lot of work. And then this is all we did when we did number 5. See how much easier that is with the proportion? Okay, your assignment for today is 7-2 practice, 1 through 6. There is not an interactive worksheet for this. This will be due tomorrow. You will take a picture of your completed work to get credit for it. Okay? I didn't do an interactive worksheet because a lot of this stuff is hard to type in. So I didn't ask you to do interactive just because of how hard it is to type some of this stuff. All right? So I just need a picture of your completed work. Okay. Don't forget you got to turn in 7.1 too if you haven't done that. I'll look in a minute. Let me finish this and edit this and then I'll look.